Welcome to This Explainer. Today, we are diving headfirst into some of the most absolute, mind-bending mysteries of the cosmos. We're going to be drawing directly on the incredible insights of theoretical physicist Professor Michio Kaku. We are jumping right in, exploring concepts that attempt to explain everything, from the exact instant of the Big Bang all the way to the potential end of the universe, and, just maybe, what lies beyond it. Listen to this. Professor Kaku throws down a massive challenge right out of the gate. He basically says that if you, yes, you, can figure out the mystery we are about to discuss, you could win the next Nobel Prize. You'd literally be declared the next Einstein. Because this is a profound, completely open question in science right now, and physicists are the first to freely admit they're currently clueless. So what is this great unsolved mystery? Well, it actually starts right in our very own cosmic backyard. Okay. Let's set up the cosmic crime scene. There is a massive contradiction happening right above our heads. Our galaxy, the Milky Way, spins so incredibly fast that based on our standard, everyday laws of physics, it should literally tear itself apart. We're talking flying off in all directions like a 4th of July pinwheel. But when we actually observe it, the Milky Way has been perfectly stable for billions of years. It just sits there looking like a flat pancake or a flying saucer. Something totally unseen is keeping it perfectly intact. So to explain why our galaxy hasn't shredded itself into cosmic confetti, physicists had to postulate a completely new, totally invisible form of matter, and here is the kicker. We need 10 times the amount of ordinary matter just to make the math work. 10 times! Whatever this mystery substance is, there is vastly more of it out there than all the stars, planets, and atoms we can actually observe combined. And that brings us to our primary suspect, dark matter. You can think of this invisible substance as the ultimate cosmic glue. Without it, our galaxy would have spun wildly out of control billions of years ago. And, well, we simply wouldn't exist. We literally owe our very presence here to this completely unseen force. But that leads to a literal billion-dollar question. What exactly is it? If it's completely invisible to us, yet it exerts this massive, galaxy-holding gravitational weight, what on earth is it made of? To answer this, physicists are turning to one of the most advanced theoretical frameworks we have. They're turning to string theory. See, for decades now, we've had these giant particle accelerators smashing atoms together, right? And they just keep finding this chaotic zoo of thousands of tiny subatomic particles. String theory steps in and proposes a really beautiful simplification to all that chaos. It suggests that all these particles aren't actually different things at all, but rather just different vibrations of a single microscopic string. It's like a grand cosmic symphony. Think about it this way. The everyday matter that makes up you, me, and our observable world, that operates on the lowest octave of vibration. But the math of string theory predicts higher, invisible harmonics. Basically the next octave up. And because these are higher, different frequencies, they don't interact with our lower octave matter in any way we can actually see. According to Kaku, this higher, unseen musical note vibrating through the cosmos, that is dark matter. But hold on, there's a catch, and it's a big one. 11. For the complex mathematics of string theory to actually work and produce all these cosmic harmonies, it requires 11-dimensional hyperspace. 11 dimensions. This fundamentally breaks our normal perception of a three-dimensional world, taking the math into realms that honestly sound like pure science fiction. And just when you think things literally couldn't get any weirder, we gotta zoom out even further. Because dark matter, it isn't the only invisible force out there. There's something even more prevalent and way more powerful called dark energy. Now, while dark matter acts as the glue pulling things together, dark energy actively pushes things apart. It is quite literally the energy of nothingness itself, and it's driving the expansion of our entire universe. If we ever want to truly understand the origin of the Big Bang, the secret is hiding right there in dark energy. Now, if your mind is reeling a bit right now, trust me, you are not alone. Professor Kaku compares our knowledge to a pancake. As the pancake of our knowledge grows larger, the more of the unknown syrup around it touches. Essentially, the bigger our view of the universe gets, the more unknowns we uncover. Physicists freely admit they're still like kids trying to grasp the basic nature of reality, building these massive detectors and launching satellites just to try and physically detect this wild, invisible realm. So, we've looked at the origins, right? The Big Bang, dark energy, dark matter, but what about the end? Will our universe just expand forever until it freezes? Will it eventually stop, recontract, and trigger a second Big Bang? Or is our universe simply not the whole story? This leads us straight into the multiverse. Imagine all of reality as this massive cosmic bubble bath. Our entire universe is just one single floating bubble, coexisting alongside countless other bubbles. And here's where the math gets genuinely wild. These universe bubbles can actually touch each other, and they can even merge together to create an even bigger bubble. You've probably seen this concept absolutely explode in pop culture recently. And yeah, it turns out Marvel Comics actually got the baseline physics right here. Sure, parallel universes and alternate realities make for fantastic blockbuster movies, but they are deeply rooted in the very real theoretical physics we are looking at today. Our universe doesn't necessarily have to die. It might just be one tiny piece of a much, much larger cosmic puzzle. So what actually happens when two of these cosmic bubbles bump into each other? They create a wormhole. It's a theoretical gateway directly through space and time. You can think of it as a bridge connecting two totally different points in our own universe, or incredibly, acting as a backdoor to an entirely parallel universe. The way we've thought about this over time is just fascinating. It actually kicks off in literature way back in 1871, when mathematician Lewis Carroll used the looking glass as a magical gateway to Wonderland. Then jump to 1935, and you have Albert Einstein providing the actual rigorous mathematical proof that these gateways could exist. And today, both modern theoretical physicists and science fiction shows like Star Trek rely entirely on Einstein's math when it comes to bending spacetime. Which brings us to a wildly thrilling question. If the math actually allows for wormholes to punch a hole through space and time, could a highly advanced civilization already be using them? We usually picture aliens taking thousands and thousands of years just to cross the void from distant stars. But if they've managed to master the physics of wormholes, they could bypass the light barrier completely. According to string theory, the mathematical solutions for these gateways absolutely exist. It's highly conjectural, sure, but mathematically, it is possible. So if these mathematically possible gateways do exist, how do we actually evaluate the evidence of visitors? Professor Kaku breaks this down using the classic encounter scale. Step 1 is the first kind. This is your flashes in the sky and military jet pilot sightings. Step 2 is the second kind. This means tangible physical evidence, like actual wreckage. And step 3 is the third kind, direct, face-to-face contact. Because right now, as a scientific community, we are firmly waiting for close encounters of the second kind. We already have plenty of eyewitness accounts and pilot testimonies of the first kind. But as mountains of government documents and UFO files finally get declassified, scientists are waiting to see if there is any hard, tangible proof hidden in there. Is there actual physical evidence of an extraterrestrial civilization that has mastered interdimensional travel? That objective search for hard, physical data is exactly what the scientific community is zeroed in on right now. From the invisible dark matter keeping our galaxy intact, all the way to vibrating strings in an 11-dimensional hyperspace. And the mind-blowing possibility of wormholes and multiverses. We truly live in a spectacular, bizarre reality. And we are just barely beginning to scratch the surface of that great cosmic pancake. The data is out there waiting for us in the stars and in the math. So I'm going to leave you with this final provocative thought. Will you be the one to finally crack the code of dark matter and win the next Nobel Prize? Keep looking up, stay intensely curious, and never, ever stop questioning the nature of reality. Thanks so much for joining me on this explainer, and I'll see you next time.